Before we jump into that, I want to start with an overview of adding negative numbers as a refresher, and we'll see why that's so important when we move to the practice problems. So as a reminder, with adding negative numbers, we kind of think about two different sets of rules. The first one is what we do when the signs are the same. That means like if both numbers are positive or if both numbers are negative. And when the sign is the same, we keep everything the same, which means we add the number and we give the answer the common sign. By common sign, I mean that same sign that you see in both of your add-ins. So here's an example here. You're given -1 and -4, and we're adding them. So I'm just going to add the numbers like they were normal positive numbers and say 1 + 4 is 5. And then because my common sign is negative, I'm going to give my answer that negative sign. So if 1 + 4 is 5, then -1 + -4 equals -5. So we see that the sum of two negative numbers is negative. You can also see that on a number line like you see in this corner. If you think about starting at 0 and you add -1, well, that's going one space in the negative direction, and that gets you to -1. And then if you add an additional -4, that is moving 4 more spaces in the negative direction, which gets you to -5. So you can also see it on a number line. Let me close my window so that sounds better. So here are a few more examples of adding negative numbers when the signs are the same, or just any numbers when the signs are the same. Our first example is two positive numbers. We don't even think about this rule here, but we have 5 and 6. We add those numbers. Both of those numbers are positive, so our answer is positive. So that's why we get +11. And then we have -3 and -4. My signs are the same. I add 3 and 4 and I get 7, and then I slap on that negative sign. Now things get a little bit trickier when the signs are different, but it's really similar. So when the signs are different, we want to think about finding their difference. And difference is a keyword telling us to subtract. So when the signs are different, we will actually be subtracting the numbers. And then we give the answer the sign of the bigger number, or the number with the bigger absolute value. And we can again see that in an example. So if I'm adding +5 and -2, the first thing I notice is my signs are different. So that tells me I need to subtract those numbers or find their difference. Well, the difference between 5 and 2 is 3. I'm just thinking about them if they were positive numbers. Now, I have to pick what sign will that be? Well, because 5 has a bigger absolute value than -2, I give the result a positive sign. 5 is greater than 2. So my final answer is +3. So when the signs are different, I subtract the numbers and I pick my final sign based off the sign of the bigger number, or the number with the bigger absolute value. Again, you can see this in a number line. If we're adding a 5, if we start at 0 and we add a 5, add +5, that's going 5 in the positive direction. And then if we add -2, we're adding, so you think it's getting bigger, but we're adding in the negative direction. So that's actually telling us to take away 2, and we still wind up at 3. And you notice we wind up at +3, not -3, because that 5 is bigger than the -2, so it wins out. You can think about that like making a series of bets with someone. If you and I were to make a bet for $5 and I won, I would win $5. If we were to make a second bet for $2 and I lost, I would lose $2. But at the end of the day, I still walk away with money because that first bet won out. It was bigger than the second number, so my final answer is positive. And that's why we always give the answer the sign of the bigger number. Again, when I say bigger, I mean the bigger absolute value. There's one note here at the bottom of the screen that I want to highlight and we'll talk about, and it says adding a negative number like we did in this problem is really the same thing as subtracting a positive number. We turned in an addition problem with a negative number into a subtraction problem with only positive numbers. want to say that here, we're going to come back to that point. But just to finally review the rules for adding negative numbers, we already went over when the signs are the same, and we just went over when the signs are different. We subtract the numbers, we give the answer the sign of the bigger number. So for example, if you have +2 plus -4, the signs are different, so I will really be subtracting those. In other words, I do 4 minus 2 and I get 2. And this time when I pick my sign, I ask myself, what number has the bigger absolute value? What number is further away from 0 in the number line? And that's that -4. And because that's negative, I make my final answer negative to get -2. So just to remember, we can think when the signs are the same, keep it the same. When the signs are different, find their difference. Now, I said this lesson was about subtraction, and I wanted to start with addition because I really want to underscore this point, and that is that subtraction and addition are reversible. We can move between them if we follow a certain set of rules. And we just saw that in the second example. You were given an addition problem, but you solved it with subtraction. The whole point here is that I know I can move between addition and subtraction if I follow a certain set of rules. And that's good to know, because if I can move between subtraction and addition, and I can solve any addition problem, then I can also solve any subtraction problem by just writing it as an addition problem. In other words, we're learning less new things by just writing subtraction as addition. And to write subtraction as addition, there's this shortcut for us, or this trick called keep, change, change, or KCC. What this means is if you're given a subtraction problem, like this top line here that says 12 minus -6, for each one of those parts of the problem, you have a different task. The first letter is K, keep. That means if my number is 12, I just keep it as 12. I don't change it at all. The second letter is C, change. That change means change the sign from subtraction to addition. That's when I change the sign. I had subtraction, the opposite of subtraction is addition, so I change it. And my third letter is C, another change. So I'm going to change the sign of the second number. Well, that second number was -6. If I want to change the sign of -6, I'm going to make it +6 or just 6. In other words, 12 minus -6, when I changed it to addition, became 12 plus 6. That's a lot less intimidating for us. 12 plus 6, now I'm only dealing with positive numbers, and I get 18. Now, it won't always work out that you can get rid of all the negatives and you'll be dealing with positives, but it will work out that you can turn subtraction into addition and use one of the 2 rules we went over at the start of this video. I'm going to see a few practice and then try some. So in this problem, we're given 6 minus +5. And again, I'm going to look to change this into addition using keep, change, change. And that's what I just did in this first step. I kept the first number, 6 stayed as 6. I changed the sign, subtraction went to addition. And I changed the sign again, +5 went to -5. So you'll notice now I do have negative numbers, but that's okay because I can already use the toolbox I have for adding positive and negative numbers. I have 6 plus -5. One number's positive, one number's negative. My signs are different, so I find the difference. In other words, I subtract. So I'm going to think about this in my head as 6 minus 5, which is 1, and this should actually be +1 because the 6 is bigger. We just did that using the keep, change, change sign. Before we move on, I want to zoom out to what else you could have done to solve this problem. Because as we're learning this strategy and practicing it, we might get in a routine of always doing it, but it's also important to zoom out and look at the problems that are in front of you. In this original problem here, we were given 6 minus +5. This might look confusing because we have that positive sign in front of the 5 in this parentheses, but we can drop that. What you were really given was 6 minus 5. It was a simple subtraction problem. You would have gotten 6, you could have solved a subtraction and said that 6 minus 5 was 1. Would have even been faster. But any subtraction problem at all, can be rewritten as addition, like we just did here. And sometimes that's easier in case the subtraction confuses us. which is like what we're going to see in this next problem. This next problem asks us to subtract -3 from 8. Well, that means I'm starting at 8 and I'm taking away -3. So I have 8 minus -3. The 8 is because I started at 8. The minus here is because it said subtract, and the -3 is because that was -3. So there's two of those negative signs. Now I'm subtracting a negative number, and that's a little bit harder for me to think about what that means. With adding, I can kind of think it through. With subtracting, it's harder. So I'm going to use this strategy. I'm going to keep change. Well, my first number was 8, so I'm going to keep it as 8. Then I'm going to change my sign from subtraction to addition. And then I'm going to change the sign of the second number from -3 to make it +3, which I'll just write as 3. Again, now I only have positive numbers. That's easy for me to work with. Good thing we tried that, because now I see this is an easier problem. I just have 8 plus 3, now I get 11. So we've got a few more practice problems here. If you are watching this video back, this is a good time to pause it to try solving these, but I can work them through now as well. So these are all different subtraction problems where we have both positive and negative numbers, and we can use this toolbox of turning subtraction into addition to solve them. Looking at this first problem over here, we're given 9 plus -3. In this top line, I didn't do keep change, and you should notice that because it was a subtraction problem and then it stayed as a subtraction problem. So I haven't changed it to addition. And that's because before I went to do that strategy, I zoomed out and I saw this was 9 minus +3. Well, that really just means 9 minus 3. I don't have negative numbers in this problem. I know how to subtract positive numbers, so I'm going to go through with that. And I say 9 minus 3 is 6. Just because we now are learning how to keep change doesn't mean you have to do it every time, and that's what this problem is showing. But if I saw subtraction and I decided I don't like subtraction, I'm going to turn it into addition, you can do that. Keep change works for every single subtraction problem. That's what I did in the second line down here. I kept my 9 as positive, I changed the subtraction to addition, and I changed +3 to -3. I got 9 plus -3 equals 6. The next problem was almost the same. It was 12 different numbers, but the same sign order. It was 12 minus +7. Again, before I went to do this strategy, I zoomed out and I thought about what's the easiest way for me to solve this. And I recognized that 12 minus +7 is really just saying 12 minus 7, which equals 5. But if you didn't see that again, you could have used keep change and turn that into an addition problem, where we kept the first number the same, we changed subtraction to addition, and we changed a +7 to a -7. Now I have 12 plus -7. I'm adding a positive number with a negative number. My signs are different, so I'll find the difference. In other words, I'll subtract their absolute values. 12 minus 7 is 5. Because the bigger number here is 12 and the 12 is positive, I'm going to keep that as +5. And the third example here, just 8 minus 4 is 4. Again, underscoring that sometimes you just know the answer without doing keep change. Got more to try. Number 4, the first question is.
Hi, Jerry. I was just looking. Yeah. So, I kind of get the hang of it now. Once you explained it, it was kind of confusing at first, but while I was looking, it seemed pretty easy.
Okay. Do you want me to flip to the next slide with more practice problems so you can try them and then see if you've got questions?
Yes.
Okay. So here's 6 questions. Take a couple minutes and let me know when you're done, and then we'll go over them.
Okay. I have a physical disability, so I can't write them down physically on my own. So huh?
You want to like tell me what you would do?
Oh yeah. Okay. Number 5.
And I can just write
So I'll put 3 plus +2.
And you get
Positive. I mean 1. It's 3.
they're both
So
positives.
Most positive, yes. It's kind of small. I can't really see on my phone. But okay, that's better. Oh, so it's 5, right?
Say that one more time.
Positive 5?
Positive 5. We can think about, it might have been easier if I wrote just 3 plus 2 that way.
Right. Okay.
Okay. Let's scroll over to the next one. Oops. Sorry about that. Uh-oh. 1 minute.
Mhm. So that's 8 plus positive 2.
8 plus positive 2.
Mhm. Equals 10.
Perfect.
Okay. So that's 11 plus positive 7.
Mm-hmm.
So that's 18.
Perfect. My phone down.
This one is, oh, this one. Keep checking. I think a negative 6. Because
Perfect. How did you get next to
9. There's 7 plus positive 1 equals negative 6. And 7 bigger.
Perfect. Negative.
This way. Uh, negative 9 plus negative 3 equals negative 6
So the
or
both
6. So oh, hold on. So this is, so we adding, right? Oh, we subtracting. So 6, negative 6, right? It's 2 negatives. Negatives plus 2. So negative 6? Sorry.
the both negative.
Oh, can't hear you.
You and I are making a bet, and the first bet we make is for $9, and I lose. So now I'm losing. I'm missing $9 from my bank account. Got negative $9 in my bank account, and then we make a second bet for $3, and I also lose it. So I have to take away another $3. At the end of the day, how much money did I lose? If I first lost $9 and then I lost another $3,
12.
$12, and I lost it. So is it going to be positive or negative?
Negative 12.
Yeah. So this is because you notice here that both of these numbers are negative, the 9 and the 3. So their signs are the same. So that's really telling me to add their absolute values or add the positive of those numbers.
Oh, okay. Oh, that was kind of tricky.
Yeah, that was a tricky one. And then here's your last test.
One is negative 4 plus positive 3.
Mm-hmm.
It was 7.
Write that one down. So we did key change flip. We did it perfectly. -4 plus 3, +3.
+3. So yeah,
Are my signs the same here, or are they different?
like different. Negative,
Different. So what do you get?
since the -4 is higher, it'd be -7.
-4 is higher, so it's negative. Perfect. There's one thing you're missing. When the signs are the same, we add them. When their signs are different, you find their difference, so you subtract the absolute values. So if you
Okay.
subtract the absolute values, you would get
-4.
just think about if they were both positive.
Also, it's 7.
What's
7
4
plus
minus 3?
4 minus 1.
Yeah, -1. So if we were to subtract the absolute values of the positive versions, that's 4 minus 3. And you're subtracting here because one of them is because their signs are different. The last one we added because the signs are the same, so we keep it the same. We keep it as an addition problem. When the signs are different, that's telling us to find the difference or subtract them. And then you saw the 4 is bigger, so it's going to be negative.
Okay.
But that's it. And then the last way you'll see these problems is in word problems, where almost nothing's different. We're still using the same strategy where we can use keep, change to solve them. But the first thing we'll have to do is be able to identify those word problems as subtraction. So here's one example for that. And this problem says, at 9 p.m., the temperature in Chicago was -6 Fahrenheit. By morning, the temperature was 7 degrees Fahrenheit. How many degrees did the temperature rise overnight?
Oh,
This is a bit of a tricky problem because it's a word problem. We have negative numbers, and we're going to see that it's kind of hard to figure out what to do. So before we start, I drew this number line here and I made it vertical so it looks like a thermometer. And I'm thinking that at 9 p.m. the temperature was -6 degrees. So that's why I drew my first line. And then I have to figure out what happens next. So because it's a word problem, I'm going to look for keywords and think, is there a keyword I see or a keyword I can come up with that tells me if I'm going to add, subtract, multiply, or divide?
subtract.
You're going to
No,
subtract
I think you said.
or add. Okay. Tell me about what you see that's telling you to do that.
Said Chicago was -6 by morning. The temperature was 7. So it rose. So it's plus. And adding how many degrees the temperature rise up by. So
So you're thinking about adding, like finding a difference between -6 and 7. And it was kind of a trick question when I said, like, is there, or like what operation to do? Because you just kind of said that, like, subtraction, addition, we can move between them. So depending on how you set it up, it could be subtraction or it could be addition. For example, when I drew this number line here, I know I started at -6 and I ended at 7. And I want to know how much it changed, how much I needed to add from -6 to get to 7. So I could just go over here and count all those spaces. Another thing I could see is, well, I want to know the difference between that starting point and the end point. Difference being a keyword telling me to subtract. So I'll subtract them. I have 7 minus -6. If you were to turn this into an addition problem, what would that be?
7 plus +6.
Awesome. Which then you just got is 13. So you can see here, you can solve these kind of like subtraction problems, kind of like addition problems, depending on how you set it up.
Oh,
Right? That's all I've got. Any questions?
That's probably my biggest challenge with word problems like this. Because I won a practice test a year ago on the website. I failed by a few points, and it's just the thing that was challenging for me. It's in fractions.
So combining this with fractions. Yeah, I think like sometimes with these word problems, like it is helpful to either draw them out or write them out because whatever way you solve it is okay. And especially with fractions, like I think if you can draw it out, then you don't have to like worry so much about the fractions, and you can just think about what's actually going on. Instead of when I try to write out all the numbers, you get kind of lost, and it slows you down.
Hold on, I'll check it.
Sorry?
Hold on 1 minute. I gotta get my nurse to do something for me.
All right, well, if that's if you're good on this, that's all I've got. So I can stick around for a couple minutes or head out.
Oh, I'm here. I'm back. Had to drink some water.
Oh, okay.
Okay, so that's understandable. So you got any more problems like this I can look at? Or
This is I can make one up. Let's see.
let's try to do this. That's a
these
bit.
are fake numbers, but so if we're thinking about elevation like sea level, and I say the highest elevation point in Ohio is 4,250 feet. That's as high above sea level as you can go. The lowest elevation point in Ohio is negative 123.5 feet below sea level. What is the difference between the highest and the lowest points?
No idea. No idea. So we're gonna have to subtract these, I guess.
And what's making you think that you should subtract?
Because that negative 1, 2, 3. So we want,
So we see there is a negative sign, but
yeah,
is that a subtraction sign or is that just a negative sign?
it's a negative sign.
Yeah, so like I'll go in here and put some parentheses around it to remind you that that negative sign belongs to that number. So it's not necessarily telling me I have to subtract. Do you see any other keywords in here that could help us get started?
The highest one. Yes.
Highest point?
The highest point, yeah.
So there's a highest point, and there's a lowest point. So we've got some key numbers here. I know my highest point, I'm just going to take notes, is 4,250 feet.
Okay. Lowest point.
And
Negative
what's my
1.
awesome? I'm going to make sure we know the lowest point is negative. So I know these are my two key numbers, but I need to know what to do with them. Am I going to add them? Am I going to subtract them? What am I going to do with them? So I'm going to go practice question. What are you trying to find out in this question?
It's see the difference between the highest and lowest points. The difference.
The difference between them. What does that mean, like in your own words?
But the difference is one is negative and one is positive. So that must mean you have to subtract from that 425, 4250 difference, 425 negative. Then we change that to, I think, okay.
Oh, I think we've lost your audio.
So,
Sheila.
so is it like the keep change process too, or is it the same as that? Okay, so for
Oh, there we go. You're back.
Okay. So difference is a word saying to subtract. So what you just narrated is that you wanted to subtract it and you kept that negative sign with the 123, which is awesome. And that's why it was important to read that the negative sign goes with the number. It doesn't mean subtract. Now you said you have a subtraction problem, so you can turn it into addition. What do you get if you write this as an addition problem?
I'll write it down. Hold on a second.
And our,
Let's see. Oh, where so we have
so does what happens to that first number?
we'll keep that at 4,250
Okay.
and then add negative 123.5.
I add a negative number. So we kept the first one. That was good. You changed the sign. What's the last step you have to do?
Yeah, we want to change that one to a positive, right? So let's keep changing things. So I think it's 123.5.
And that's positive. So
Okay.
now we did that. Now we're just adding two positive numbers.
So I got 4,373.5.
373.5. Perfect.
Okay.
And what's the unit on that?
I'll say it again. I'm sorry.
What's the unit of that answer?
Feet.
Feet. Perfect.
Oh,
So the difference between the highest and lowest is 4,373.5. If you zoom out all the way to the beginning of the problem and think if you have a high point that's 4,000 plus feet above sea level and your lowest point is below sea level, it makes sense that that number is so big. The number is kind of big enough to represent that difference. So we can,
sure.
okay. So the temperature at 11 p.m. was negative 3 degrees Fahrenheit. We'll pretend that it's not the middle of summer. The temperature dropped 6.5 degrees Fahrenheit overnight. What was the temperature in the morning? So when you read the problem, in general, what's this problem about?
Temperature.
Temperature.
Yes.
And then what are you trying to find out here? What's your final answer going to look like?
Trying to find out how much was the temperature was at 11 p.m. It's dropped 3 degrees. The temperature dropped 6 degrees overnight. So,
In other words, what don't I know?
uh, temperature, the temperature overnight for the morning.
The temperature in the morning. Awesome. So I want to know the temperature in the and then what information is important that might help you figure out the temperature in the morning? What do you see in the problem that might guide your thinking?
The 3 degrees and the 6.5 degrees.
It was 3 degrees, or what was the original temperature?
Yes, it was -3 degrees.
Start at -3 degrees.
Yes,
And then what happened?
it dropped 6.5 degrees overnight.
Dropped 6.5 degrees. Awesome. So it didn't just change 6.5, it dropped 6.5 degrees. If
Okay.
it dropped 6.5 degrees, did that 6.5 degrees, is that like a positive 6.5 or a negative 6.5?
-6.5.
We're going to take away 6.5 degrees overnight. And then we want to know final temperature. So, any ideas here? Now that
Write it out. So I think it's -3. Uh,
oh, sorry.
okay. -3 minus -6 and 6.5 degrees. So -6.
So,
Trick.
I think this was my bad. Sorry. So I started at -3 and then I took away -6, or I took away 6.5. So there are two ways you can think about this problem. I think I kind of confused you as you were saying it. We can either think about this as starting at -3 and taking away 6.5. So in other words, you can think about it as -3 and then taking away 6.5. Or you can think about it as starting at -3 and adding -6.5. And that's because that word dropped could mean, we could interpret that in two ways. We could say, hey, that means it dropped, we're going to take away. Or we could say, hey, that means the 6.5 is negative. So either way, fine. Are these equivalent? Is -3 minus 6.5 and -3 plus -6.5? Does it make sense that those are the same?
No, I'm not. Because the half, we gotta do something with that, right?
So don't worry quite about the half yet. When you're looking at these two problems, the one that I have written as subtraction and the one that I have as addition, do those equal each other? Is this true?
Yes.
Yeah, because if you keep page flipped, you would notice the -3 stayed the same, the subtraction went to addition, and the positive 6.5 went to -6.5.
Okay.
Which one looks like a more inviting one to solve?
The second one.
The second one, right? Feel better with addition. We're going to do that. Now you said, I know I have to deal with the fraction. Before you do that, I'm adding sign numbers. My first question, are my signs the same or different?
It's same.
They're the same. So that means I'm going to really add or really subtract.
Subtract.
If my signs are the same, I keep it the same. So I keep it as an addition problem. And my signs are the same, so what's the sign of my answer going to be?
So negative. Oops. -3.5.
Ooh, really close. So thinking way back to our additionals at the beginning, as a reminder, when the signs are the same, like here, you said they're both negative. That's
Right.
saying I can keep everything the same, and I can just add the numbers as if they were
Oh,
both positive.
oh, okay.
And
So,
I'm going to think about this as really just 3 plus 6.5. If I were to
okay.
give you 3 plus 6.5, I kept it the same, I made them both positive. What's 3 plus 6.5?
9, 9.5.
9.5. Awesome. So if 3 plus 6.5 is 9.5, what's negative 3 plus negative 6.5?
So it's negative 9.5.
Awesome.
Okay. Yeah.
So when the signs are the same, you're just adding the numbers as if they were positive. And it's when the signs are different, like if I added a negative sign here, that's when I'm really subtracting. So if I were to give you this problem right here, what would you get? Sorry. If you did negative 3 plus 6.5.
Yeah, so that would be positive. 9.5.
Positive. Why do you know the answer will be positive?
Because the 6 number is bigger.
Awesome, the 6 is bigger. And my signs are different. So what does that tell you have to do?
Subtract.
Subtract. So pretend like the numbers are positive and just subtract them. What do you get?
Negative 3.5.
6.5 minus 3. What would you get?
6 minus. Negative 3.5. Oh, 6.
Super close. What's 6 minus 3?
3.
3 and 1/2 minus 0.
0.5.
5. So if I subtracted these, just as if they were positive, I get 3.5. And you said my final answer here is going to be positive or negative.
Negative.
Which number's bigger?
Oh, 6 positive.
Positive 6, so that's going to be positive.
Okay. Oh,
Going to give
okay.
Right. I want to do these three as the last 3 problems.
Okay.
I know it's addition, but because you're feeling good turning subtraction into addition, want to zone in on this addition. Walk me through it.
For the subtraction, so keep the first number, change the sign to negative, and just positive 7. So that would be um, the,
Awesome. So you just use keep saying change well to turn the addition problem into subtraction. Looking at this top line, we have an addition problem here and a subtraction problem here. Which one is easier to solve? An addition problem or subtraction problem?
subtraction problem.
The subtraction problem? Okay. So if you're at negative 84 and you take away another 12, where are you going to land?
Negative 72.
Super close. I want to think about it. Number line. All right. If I'm right here at a number line, I'm at negative 84.
Okay.
All right, let's pretend 0 is over here,
Mm.
right? Because negative 84 is going to be on the left. So with that?
Yeah.
Okay. If I'm at negative 84, you're subtracting 12. That means you're taking away 12. If
Right.
you take away, are you going to get closer? Are you going to get more positive or more negative?
More towards the positive because subtracting towards the negative.
If I owe you $84 and then I owe you another $12, is my debt to you getting more negative or more positive?
More positive.
So I would owe you less money?
More money. Probably do that. And see closer. We go a little bit more. Negative 84 minus 12. That's 72. Negative 72.
84 minus 12 is 72.
Yes.
That you're right on. Instead of thinking about this like subtraction, because we're going to come back to thinking about it like subtraction, I want to actually look at the addition problem first. We're going to do the subtraction problem in a second. Ah! Oh.
6.
So here's the problem written as addition.
That's negative 84 plus negative 12. Um,
Your signs are the same, so I want you to think about just adding these numbers as if they were both positive.
okay, so it's 96.
96. And then is that going to be positive 96 or negative 96?
Negative 96.
Perfect. So anytime, works every time you see an addition problem with two negative numbers, just think, what would I get if they were both positive, and then make it negative.
Also, we added, okay,
So when they're the same sign you add, you keep it the same as addition. Now, we're going to kind of come back to the number line now. Here's a different problem. This is negative 84 plus 12. What makes this problem different than the one we just did?
because they different. So
Because what?
the negative 84 plus 12 is different. So being at the negative front of 12, so
So we lost this negative sign. Perfect.
Yeah.
So are both of my signs the same here?
they're both different.
No,
One
they're
negative.
different. Good. One's negative, one's positive. That's telling me my rule is going to have to be. If my signs are different, that's telling me I really want to find the difference of these, or want to think about if these were positive and I subtracted them, what would I get? So if you think about positive 84 minus positive 12, what would you get?
Positive 96. But
It's like 84 minus 12.
minus 12. Oh, shit. Okay. So that's 72.
72.
72,
So
yeah.
unlike the last one where I said think about both of them as positive numbers and add them, in this one, I have to think about them both as positive numbers and subtract them. And the rule is different because the signs are different. So it's 72. Is it going to be positive 72 or negative 72?
Negative 72.
Negative 72, and why?
Because the 84 is bigger.
Awesome. The 84 is bigger, is a bigger absolute value. Is good.
Oh, 4. Oh,
So looking at this last one here, before you solve it,
oh, say it again. I'm sorry, you're breaking up.
can you hear me now?
Yes.
Okay. Before you solve this last one down here,
Mhm.
can you look back at the first two problems and pick which one of the first two problems is this one most similar to?
The first one.
The first one, what makes it similar to the first one?
Is it a -12?
Awesome. So just like the first one, there's a -12. And what makes it different from the second one?
It's different because it's +12 and the other one is -84.
So both of the signs switched. So those are two things that are different.
Yes.
Can you think about something that makes these two problems similar to each other?
It's just a plus sign.
They
Yeah,
still have they're both adding. In this problem, were my signs the same of these two add-ins? Were my signs the same or were they different?
They're different.
They're different. What about in these two?
They're different.
They're different. In this one, my signs were different, so we thought about this like subtraction. In this one, my signs are different, so what will you still think about it like?
I think we this one kind of complicated. I think we have to add that one because it's a plus. We just keep
Okay,
the
so no, it's a plus sign, but if one number is positive and one number is
negative. Right. The 184 is positive and -12 is negative. So keep change. So we have to
what would you
subtract.
get if you change what?
I'll say it again. I'm sorry. 80. Let's see. Not to do this one. Okay, 84 negative. I mean minus positive 12 equals 72.
Awesome. And is it going to be positive or negative?
Positive because the 84 is bigger.
Awesome. So you'll notice in these two, you got 72 both times because you thought about them both as subtraction ones. In this one down here, we used to keep change flip to think about it like subtraction. In this one, you thought about addition rules to think about it as subtraction.
Okay.
In this one, it's negative because the 84 was negative and the 84 is bigger. In this one, it's positive because the 84 is positive. So if you can turn all of them into subtraction and subtraction to addition, that's great. My one big takeaway that I want to remind you of, and I'm going to go back to the beginning to show you these rules.
Mhm.
You all needed these.
You think you email me that copy of that so I can have for my notes?
Mhm.
Science.
Yeah, can I get your email?
J as in Jack, L as in Larry.
L is in Hillary.
Yes, Larry. Last
Larry.
name Motley, and that's 84@gmail.com.
Right? Awesome. I can send this to you. So the big reminder here is anytime you have problems where the signs are the same, as in they're both positive or they're both negative, you're really going to add them. So you see that in this box down here. Here they were both positive, so I just added them.
Okay.
Here they were both negative, so I just added them as if they were positive, and then I gave the negative. But when the signs are different, like those final two problems we did, you really want to think, my signs are different, so I'm going to find their difference or subtract them. For example, in this problem, we have +2 plus -4. my signs are different. This one's positive and this one's negative. So I have to find their difference. In other words, I'm going to pretend like both numbers were negative, both numbers are positive and subtract them. 4 minus 2 is 2. And then I'll make it negative because my bigger number is negative. So I'll
Okay.
email this to you, and this is true for any time you add positive and negative numbers, which means you just said that anytime you subtract positive and negative numbers, you can turn it into an addition problem, which means you can use these two rules and keep change solve any problem.
Okay.
Right? Cool. That's all I got. I will send this to you and hope you have a good night.